Okay, let's redo this problem. Okay, you are in a large lecture class, economics course, and the professor never announced the mean of the exam, most recent one. So just you are curious that you find the sample of 10. You asked around, and you found the sample mean is 76.8 and the standard deviation of 9.9. And you want to construct a 95% confidence interval. In order to do that, yes, point estimate is your evidence, your sample. Your sample mean is this. Around here, you are going to compute the error, add it, and subtract it, correct? Okay? So when you do that, we can do by hand and by calculator. So let's use a calculator first. So you are going to do stat, and then go to test, and then go to number 8. Okay, number 8, t interval. Okay, whatever the number is, t interval. And then you enter that x bar is 76.8, the sigma is 9.9. Okay, and the confidence confidence interval, the level of confidence is 95%, so 0.95. Okay, once you enter that, you are going to have an interval of this is 69.718. And here is 83.882. You use a calculator and then you can get that. Okay, so in other words, your sample says the mean is 76.8, but when you estimate this entire population, the whole lecture class, the mean is between 69.7 and 83.9. That's what would you say. Okay, so this is a confidence interval. Well, when you do this use a calculator, you have no sense of how do you use this 95 over confidence interval over here, how it is incorporated. So this time, let's by hand. In that case, you are going to calculate margin of error yourself. Okay? So margin of error is it's going to be t sub alpha over 2 times s over square root of n. It's not too bad. This alpha here is 95%. That means alpha is 5%, which is 0.05. So alpha over 2, because we spread out in both directions, so alpha over 2 is 0.025. So you go to t sub 0.025, and s is 9.9 divided by square root of 10. Well, when you go to t distribution, what do you look at the first? Yes, you are going to start with the degrees of freedom, that is 9. You start from 9 and then go to that number, 0.025. What you get is 2.262. So 2.262. And then multiply by 9.9 over square root of 10. Okay? Once you do that, you are going to get 7.0815. So this is your margin of error. So when you add this one over here, you get this. Yeah, obviously this time you make this one as a 7.082. Okay, 7.082. Add this and then subtract this, you get that. Okay, so this is a margin of error, and this is where you can see that really this confidence, level of confidence is really incorporated in your calculation. When you see the calculator, you don't see it, just you punch the number, just 0.95, and then that's it. Okay? Well, can you get this answer easily once you have the interval? the thing is, I kept saying you add error and then margin of error to get this number. Therefore, once you get the interval, interval is known if interval is known. In that case, what do? Use upper bound minus point estimate. Okay, and then once you subtract it, you are going to get this answer. So margin of error you can compute like this, or from the interval you can conclude that. Okay. And number 5. Number 5. In February 2005, Harris Poll conducted a survey, and then 769 of 1,010 randomly selected adults said that they always wear seatbelt. Okay, so they always wear seatbelt. I don't know those who don't wear seatbelt. I don't know what they are thinking, but anyhow, this is the result. Construct and interpret a 98% confidence interval for this. All right, so construct a 98% confidence interval. Okay, so what do you have to do? What is, first of all, 769 over this. So our p-hat, our evidence, okay, our evidence is 769 over 1010, which is 0.7614. Okay, so this is our evidence we are going to construct. Okay, so what can you do? You are going to have, yes, okay, when you want to do confidence interval, the Z interval, previous one was what? Previous one was T interval, wasn't it? Okay. Well, it was about population, the score, the average of the exam. That was a T interval, so this time it's going to be Z interval. Yes. Yeah, I was a little bit confused about, which one. Yes, you can do STA, test, and then go to A, option A. Option A, 1 prop Z interval, 1 prop Z interval. Okay, so let's do it. Stat, test, option A. 1 prop Z interval. Yes, not just Z interval, okay? Yes, 1 prop Z interval, and you enter these numbers, okay? 769, 1010, and the confidence level 0.95. Oh, this is 95 or 98. Yeah, 98%. So I'm sorry, 0.98. Yeah. So that gives you 0.7310019, 0.79259. Yes. Okay, so construction, this is a confidence interval. Okay, so roughly you can say this is roughly 73% to 79%. Yes. So how do we interpret this 98% confidence interval? Well, what that means is you make your sample, another organization make another sample, so you can make many samples of 1010. It's not very easy though in this case, okay? It's not like the previous case, like just you ask 10 people in the class and then make a sample, 1010. And as you make a sample, you can construct another interval, another interval, another interval. So that means when you make many intervals, 98% of those intervals will contain true P, true proportion, which we do not know, which we will never know. Okay, which we will never know, but 98% of intervals will include true proportion. That is understanding. Okay, it is not about this one particular interval that there is a chance that 98% of probability that this one has a true value. It sounds very similar. However, our understanding has to be, again, there are many intervals can be created. Out of that, 98% will contain the true value. Okay, number 6. Number 6. So, given that a population of scores is normally distributed with a mean of 105 and standard deviation of 9, determine the following. Okay. So you have a sample, yes, you have a sample that is, mean is 105 and the standard deviation S is 9. Oh, the population, I'm sorry. So, population. So mu is 105 and the sigma is 9. Okay. From here, a random sample of 30 students. So sample of n equals 30 is taken and the average is x bar is 98. Yes, this one you are going to have, yes, the about hypothesis, okay, test. So here, 30 students yield an average of 98. Do the data provide sufficient evidence to conclude that the mean score of a population is actually less than 105? Look at that. The population, the mean is 105. Here, what you have a sample is 98. There is a big difference over here. So is it sufficient evidence that to say that really the average is, the mean is less than 105? Well, so we are going to see that. So what is, first of all, hypothesis? Okay, make a hypothesis. So H naught says mu equals 105. On the other hand, the alternative hypothesis is that mu is less than 105 based on our evidence over here. Okay, we want to claim that. I don't know whether we are going to reject this one or not. Okay, so that means this is good, sufficient evidence or not. We have to test. So what kind of a test are you going to do it? It's less than 105. So we are going to set up the rejection area, which is called the critical region. So here is 105 and test statistic. Okay, so test statistic, so go to Z. Okay, this is because this is about the mean. Oh, I'm sorry, about the mean. So this is a t distribution. Okay, and we are going to do test. Well, here is, we are going to have what is the significance level. Use significance level is, significance level is 0.01. So less than, so what kind of test is that? This is left-tailed. So going over here, this area is 0.01. So this is what we mean. Okay? So go here and find this t value. So this t value, this t is going to be invert t. Okay? Invert t. Yes. You are going to say that. And here the area is 0.01, and degrees of freedom is, well, degrees of freedom is 29. As soon as you put in there, this t value is negative 2.462. You can go to the table also, okay? You can go to the table. So this is the rejection area. 0.01 is area, and this is a t value on this number line, okay? So what are we going to do? Yes, we have our test statistic. This is our evidence, and we are going to see this, our test statistic is where it is located in this t distribution, okay? So what is a t statistic? The t naught is x bar minus mu naught over s over square root of n. X bar, finally we are going to use our evidence, which is 98, minus mu naught. Mu naught, we do not see mu naught, but this naught means the mu value that is used in H naught, which is 105. Okay, S is 9. S is 9, and the square root of n, that is square root of 30. Okay, square root of 30. So what is that? Once you calculate, as you see, it's going to be negative number. It is a negative 0.1826. Okay, 0.1826. So you are going to locate that in here and then see if this number falls in this critical region. Another way, easier way to understand is rejection region. Okay. So this one is negative 2. Hey, this one is negative 0.1 something. So it's going to be over here. 1826. So it does not fall in this region, rejection region. So we do not reject. Okay? So our conclusion is we do not reject. Reject H naught. Meaning, our sample shows us just lower than this, they claimed, okay, or in the past. Well, but it is just one kind of just variation, okay. It's not unusual case. If it's unusual case, in other words, falls in this area, falling in this is equivalent to say that that is unusual. But it's not the case, so that's why we do not reject H naught. Okay. And this one, critical value, yes, we call this critical, I'm sorry, not a critical, critical value is this, yeah. This is a test statistic. and this is critical value. Okay, so we are going to locate in here and then see if it is in the rejection region. Yes. Okay, number 7. Number 7 is about the concept, okay? The null hypothesis. 1, 2, 3 options. Number 1 symbol is H1, I'm sorry, it's H0, right? Okay. Is always stated in terms of population parameters, okay? So it's about mu, or it's about P, or it's about sigma, which we do not do, okay? B, changing the level of significance from 0.05 to 0.01 is do what? Well, look at this. When you make this significance level, where do you use it? In order to use critical value over here. Critical value comes from your what? Comes from the significance level, okay? That comes from the significance level. So if you have alpha equals 0.05 versus alpha is 0.01, well, that one is going to be, think about it, that is z sub 0.05 versus z sub 0.01, okay? 0.01 means the right side, the area is, this area is 0.01. 0.05 means this right side, this area is 0.05. So these are the shaded part, are the rejection regions. So when you decrease this significance level, that means you decrease the rejection area. Okay, so decreases the rejection region or rejection area. Yes. All right? So just understand, just as using a picture, alpha indicates the area of the region 2 is right. So this portion and this portion, smaller portion, so rejection region is smaller. Okay, number 8. Okay. SeaWorld claims that more than 35% people visit the park in summer when they come to Orlando. All right. So do we understand this concept? Yes, SeaWorld people claim that 35%. So here is Orlando. Here is SeaWorld. Okay. Those who came, not everybody goes to SeaWorld, so 35%. And the SeaWorld